Scotland is celebrated worldwide for her natural beauty. Her wild glens and moors, her deep lochs, her rugged mountains and magnificent coastline. It's hard to imagine man has made any impact at all. But every square inch has been affected by centuries of human activity. I'm going to look at how man made Scotland's landscape and how this history has shaped the present. This week, the climate. We've been shaped by it, struggled to understand it, and now we're even changing it. This is Whiteley Wind Farm. It's the biggest onshore wind farm in Europe. 140 turbines spread across Eaglesham Moor, just to the south of Glasgow. Every one of these turbines can generate enough power for 1,000 homes in the city below. Across Scotland there are currently 70 more wind farms, and another 200 are planned to follow. They will transform our landscape and will eventually supply over half the wind power of the entire United Kingdom. But they're more than mere electricity generators. These wind turbines are frontline soldiers in the battle against climate change, in an attempt to use Scotland's natural landscape to combat the threat of global warming. Today, concern and debate about global warming grips the world. But it's a spectre we've done this to ourselves that really haunts us. And it's our addiction to carbon-based fossil fuels that's blamed. In many ways, that addiction was kick-started right here in Scotland. In the centuries of the Industrial Revolution, it was Scottish engineers and entrepreneurs who let the carbon genie out of the bottle. Today, these turbines represent the latest twist in the dramatic story of Scotland's relationship with the climate. A story that's seen the people and landscape shaped not just by human forces, but by natural ones too, for thousands of years. During the winter of 1850, a great storm raged across Orkney. It tore away the grass from a large dune known as Skara Brae. Beneath the sand, the ruins of ancient stone buildings were revealed and provided a clue to how past changes in climate transform not only lives, but entire societies. As archaeologists began digging, they soon realised that the storm had uncovered the best preserved Neolithic village in Northern Europe. You know, it's extraordinary to think that people lived, loved and died here centuries before construction began at Stonehenge. This much we know, but there's mystery here too. When archaeologists were excavating the stones of Skara Brae, they discovered something intriguing in the rubbish: seeds of wheat. For seeds of wheat to grow, you need long, warm summers. Not too wet, not too windy, not what you usually find on Orkney. Today, winds of 90 miles an hour regularly rip across the island, and it's around 2 degrees colder than the Scottish lowlands. If wheat grew here 5,000 years ago, the climate must have been different, both warmer and less stormy than it is now. And there's more. Further archaeological excavations found mounds of shellfish and cod bones, and on an island stripped of trees today, signs of clusters of birch, hazel and willow, woods that would have sheltered red deer and boar. This must have been an island paradise. The archaeological record begins to vanish around 4,000 years ago and shows no sign of struggle or conquest, no wreckage or skeletons. Instead, it seems, idyllic Skara Brae was voluntarily abandoned. The question is why? One way to understand what happened to the people of Skara Brae 4,000 years ago is to come here, to this loch, Loch Inch in the Cairngorm Mountains.
1, 2, 3. 1.
Here, scientists like Professor Mary Edwards have a way of travelling back to the time of Skara Brae, travelling in mud. The sediments here are a kind of diary. And if you know how to read them, they reveal much about the past. I always get a real kick out of realising that these lake bed sediments are archives of the past. You know, you see, it's like seeing the past emerge. Do you get a real kick out of this moment? Because you're never sure what you're going to get until you get to extrude it in this way.
It's very surprising, and you get very excited, and you want to sort of poke it and prod it and see if there's anything catches your eye.
It's fascinating. At which point here were the pharaohs building pyramids and you know, when was Skara Brae and all the rest of it, isn't it?
That's right.
It's fascinating. So what kind of indicators are in here?
A lot of different ones. Pollen, obviously, for vegetation, and little seeds, perhaps, or bits of plant material could be in there.
Rootlet, maybe?
Yep, things like that. Little bits of wood, even washed off the shore. We can see volcanic ash layers that are derived from big eruptions in Iceland that blow across the Atlantic, and it's pretty well known when they occurred. So they actually give you time moments. And then as you move through, you actually then start to see further changes. So you'll see it's pretty warm, pretty nice. Things are growing well. And then the climate just starts to tip towards being not so good. Some quite serious decline in the general climate and some quite strong climate events.
Adding information from mud cores like these with the archaeological evidence reveals that the people of Skara Brae experienced one of these climate events. Today, the average temperature in Scotland is just over 7 degrees. Between 4000 BC and 3000 BC, Scotland enjoyed a warmer climatic period when temperatures were a couple of degrees higher than they are today. But then temperatures began to sink by 2 degrees. 2 degrees that would have made a significant difference. Stormy winters, wet summers, failed crops, famines. The idyll of Skara Brae was shattered by climate change. The cores go on to tell what happened next. Between 4,000 and 2,000 years ago, the temperatures slowly fluctuate. Then they rise sharply through a medieval warm period, and then they plunge rapidly, the beginning of a period we now call the Little Ice Age. Starting in the 14th century, the Little Ice Age was around 2 to 3 degrees cooler than today and lasted for 500 years. An interval that brought not just snow, but storms as well. Some of the worst storms ever recorded. So bad that their effects are still visible on the landscape today. Culbin Sands on the northeast coast of Scotland is a remarkable landscape of sand dunes that hold Britain's largest coastal forest. Long before the forest was planted in the 1930s, the bare dunes stretched far inland, where they concealed something even more remarkable. Rolling farmland. Under the roots of this Culbin forest are the remnants of a great house and its fertile fields and orchards. A land flowing with milk and honey, which disappeared in its entirety during the course of a single night. That night in late 1694, a huge storm struck from the north. A report from the time tells of hurricane-force winds at sea. On land, this shore bore the full brunt of its violence. Sand was blasted from the beach, across the fields, covering everything in its path. It was a weather event so extraordinary that it was recorded by a witness, one John Martin of nearby Elgin, who wrote, "The wind comes rushing down through openings between the hills, carrying with it an immense torrent of sand, with a force and violence almost overpowering." It's said that the storm lasted for 30 hours. When the villagers returned the following day, they found their homes buried and their fields a sandy wasteland. An area of farmland that was so fertile it was known as the Granary of Moray was lost forever. The great Culbin dunes are still accumulating sand. But today, the trees act as the sand's anchors, pinning it to the coast, where it belongs. All of this the legacy of one very stormy night during the Little Ice Age. The people of Culbin Sands looked for answers, and they found the explanation in their own behaviour, in the acts of man. In this case, one particular man, their laird, Alexander Kinnaird. It was said he played cards on the Sabbath, was in league with the devil. The storm had been God's punishment for his sins. There was more divine punishment to come as the Little Ice Age reached a peak of its terrible power. The years following 1694 brought more hurricane-force winds and numbing cold. Thousands died, thousands more left the country. There were reports of the poor roaming across the countryside, desperately seeking food and charity. Many starved, dying where they fell, unburied bodies littering the roads and fields. When these victims of the weather sought spiritual comfort, they received just condemnation. Scotland's ministers stood before their congregations and preached hellfire and damnation, because this was a biblical famine, a clear sign of God's fury, a just punishment for a sinful nation. This is a flavour of the cold comfort dished out at the time. The wrath and displeasure of God is visible against us in the unkindly cold, whereby God threatens to blast our expectations and hopes of the fruits of the earth. Hellfire and damnation was cold comfort indeed. The inhabitants of Culbin were as ignorant as those of Skara Brae about the real causes of their misfortune. They were unaware that it was the entirely natural rhythms of the Earth's orbit, volcanic explosions, and the behaviour of the sun that was controlling the climate. They would also have been unaware that the world was on the cusp of a period of technological change. They would see a new climactic force, the influence of man. At the birth of that process was a handful of bright, industrious Scots. This picture illustrates one of the great fables from the history of science. It's 1751, and in a Greenock kitchen, a 15-year-old boy sits watching a kettle. Watching and thinking. The boy is James Watt. In the picture, he's regarded kindly by his aunt. His cousin tells a different story. Jamie Watt, I never saw such an idle boy. For the last hour, you've spoken not one word, just taken the lid off of that kettle and put it on again. Holding now a cup, now a silver spoon above the steam, watching how it rises out of the spout and catching and counting the drops of hot water. Of course, we all now know that this was no idle dreamer. Young James stored away his observations, and years later, he designed a new condensing boiler that made steam engines more powerful and more efficient. It kick-started the Industrial Revolution. Steam engines drove pistons, cranks and trains. Drove belts, looms and lathes. The number of factories exploded, connected by a web of railways. Steam was the driver, but it was all fueled by this: coal.
Coal's fascinating stuff. It's hard to believe it's the fossilised remains of long-buried forests from 300 million years ago. It's almost pure carbon. In a way, this material is like the alchemist's stone. It's transformed the fortunes of those who owned it. Industries, even cities, have been built on this.
It certainly transformed Scotland. James Watt's invention helped to create a huge demand for coal. At the end of the 18th century, 1.5 million tonnes of coal were extracted every year in Scotland. By 1870, that figure was 17 million tonnes. The Central Belt contained one of the richest seams in Britain, and the heartland of the Scottish coal industry was soon established all around my hometown, Glasgow.
In the 19th century, Glasgow was a boom town. It resonated to the sounds of the Industrial Revolution, the clank of metal, the roar of machines. It was a city full of smokestacks, pumping out noxious fumes.
The tallest of them all was the St. Rolloch's chimney. Built in 1842, it was 400 feet tall and was known locally as Tennant Stock. It was named after Charles Tennant, the Scottish industrialist, founder of the St. Rolloch's Chemical Works, which by the middle of the 19th century was the biggest chemical plant in the world. and was using 30,000 tonnes of coal every year. Industrialists like Tennant generated huge profits and vast numbers of jobs. And he wasn't alone. There were dozens of Tennants, hundreds of factories using millions of tonnes of coal. They transformed Glasgow, turned it into the workshop of the world, the second city of the empire. But this furious transformation came at a price. Pollution gave Glaswegians one of the lowest life expectancies in Britain. And while the effects of that pollution on people and on buildings was plain to see, its effect on the atmosphere was not.
This beautiful loch up in the Galloway forest is miles from anywhere. For generations, the water's been popular with local fishermen. But at the end of the 19th century, the fish, mainly brown trout, had almost entirely disappeared from the lochs around here. Those that remained were horribly deformed, often with half a tail or fins missing.
Various theories were offered up, a favourite being that the fish scraped themselves against the sharp bedrock. But it wasn't the rocks that were causing the deformities. It was pollution. Noxious pollutants that were being pumped from the coal-fired engines of Northern Ireland, Northern England and Scotland. Gases like sulphur dioxide. When these emissions made contact with water in the atmosphere, sulphur dioxide turned into sulfuric acid.
They fell as acid rain in the lochs of southwest Scotland. And the fish were poisoned and deformed. These lochs have been collecting pollutants since the start of the Industrial Revolution.
The water had become acidic as early as 1800. The fires of distant industry to blame.
The moral of the story is simple. What goes up must come down. That's heavy weather.
Heavy weather indeed, and a forewarning that human activity could alter the atmosphere. Sulphur dioxide wasn't the only gas being released by burning coal. There were others, including an invisible and odourless gas. One that occurs naturally in the atmosphere and is also created when the carbon in coal burns on contact with oxygen in the air. Carbon dioxide. By the middle of the 19th century, carbon dioxide was being released from coal like never before. And thanks to another Scot, would soon be released from another vital natural resource, oil. James Watt gave the world power. James Young gave the world light. Born in Glasgow in 1811, James Young was a chemist and an entrepreneur. Young literally greased the wheels of industry, supplying lubricants to mills and factories. But his supply of oil was running out, so he turned his inventive mind to finding a new source.
It looks as though we'd have to make oil for ourselves. Make oil for ourselves? My plan is to get the oil from coal by distilling it. Friends sent me some samples a few weeks ago, which they found near Edinburgh. Here is some of it. Of course, it'll have to be distilled in a special way.
It may sound improbable, but it was, Young knew, potentially very lucrative indeed. Young continued to hunt for samples, and 20 miles from Edinburgh, he found just the one he was looking for.
It's called turbinite. And it's a kind of a mixture between a coal and an oil shale. It was first mined just west of Edinburgh, a hill called Torbane Hill, which is why it's called turbinite. And it's amazing to think that it's this rock that really kick-started an industry that kept tens of thousands of people in jobs in the central part of Scotland. Now, to do this, I need to get a pestle and mortar and smash it down a little bit. You can smell it already. It's an oily, kind of diesely smell, as if you're in a petrol station coming out. That's nice, look at that. Nice, clear, bright flame. But what you don't really see here is that there's vapour's been given off, and it was those vapours that turned out to be the real important thing. Now, what we've got here is what's called a cold finger condenser. It's basically a test tube, inside of which is a condenser where cold water runs through. Pop this on, set the water off, and then what I'm going to do is heat it once again, but this time, what it's going to do is the vapour's going to come off and condense against the cold water and line the outer side of the condenser. And then, look at that. Crude oil. It's amazing to think this simple process was the start of Scotland's oil industry. Absolutely stinks.
In 1851, James Young opened his first manufacturing plant in West Lothian. Paraffin for lamps and candles started as a byproduct, but they soon became the most profitable part of his business, and the wax became renowned for the brilliance of its light. Young piled up the superlatives. First holder of a patent for distilling oil from shale. First commercial oil works in the world. He piled up his rubbish too. What was left after the oil had been extracted was collected in these heaps. It's what I call a carbon footprint. Others call them bings.
The story goes that there's so much oil in here that it used to seep into the streams below. And the locals used to set it alight.
Close up, the shale pieces look rather lovely. There's still a lot of it around, which isn't surprising. For every tonne mined and burned to extract the oil, 80% ended up as waste. What's astonishing is that the other 20% proved to be so profitable.
For a short while at least, this small patch of Scotland could honestly call itself the oil capital of the world. It became the centre of global oil production where, thanks to Young, thousands rushed to get in on the oil boom.
And shale oil didn't just burn in lamps. It would be used to produce a new fuel called petroleum. Today, the shale bings are being used to build roads on which we'll drive our petrol-fueled cars. Quite possibly until all the oil runs out and the age of carbon is finally over. The amazing innovations of people like James Watt and James Young helped us establish our industrial society upon a finite amount of natural resources. An age of belief in progress today, with no thought for the consequences tomorrow.
The great Scottish writer Thomas Carlyle captured the spirit of the age best when he wrote, "We remove mountains and make seas our smooth highway. Nothing can resist us." we war with rude nature, and by our resistless engines come off always victorious and loaded with spoils.
Spoils indeed. Foul air and poisoned people. Polluted rivers, blackened buildings. And if Watt and Young helped start the age of carbon, they also ushered in the age of carbon dioxide. Every ton of coal burned gave off 2 tons of it. Every ton of oil released more than 3. Invisible and odourless, a harmless byproduct of industrialisation. Or was it? One of the first people to speculate about the effect of carbon dioxide on the Earth's atmosphere was John Tyndall. Tyndall was a professor of philosophy at the Royal Institute and a keen mountaineer. On one trip to the mountains, his sharp eyes noticed the tracks left behind by once vast glaciers. His sharp mind did the rest. In 1859, he speculated that to cause glaciers to melt, the climate must have changed, and that one of the gases in the air, such as carbon dioxide, might well have caused it. So he set out to test his theory. Today, using simple laboratory equipment, we can demonstrate the experiment he conducted.
Talk me through it, what have we got?
What we have is we have 2 bottles. This one just has air in it, and this one has carbon dioxide. It's been filled up so that it's now got a much higher percentage carbon dioxide content than this one here.
So a kind of miniature atmosphere and a miniature atmosphere enriched with CO2.
Absolutely. It's a sort of extreme version, but this is what the atmosphere would be like if you keep putting carbon dioxide into it, I guess.
So what do we do to kind of
What we're going to do is we've got our kind of sun simulator. We've got this massive light here that's going to be the sun. We're going to shine the light on them, and what we should find is that the carbon dioxide one heats up much quicker than the air one.
And these are recording the temperature then in the canisters?
Absolutely. So the 2 of these are currently at the same temperature, because the same temperature inside the 2 bottles, because we've had them lying around for a little while. And what we've done is we've put the sun in between the 2 of them. And the idea is that this should heat the 2 equally. So we're trying to keep everything as fair as possible.
OK. So shall we turn the sun on?
We shall turn the sun on.
Whoa.
In just a few short minutes, the flask containing more carbon dioxide warms to become hotter than the flask containing just air. A full 2.5 degrees.
So that's because the CO2 in here is kind of holding on to the heat and not letting
let it back out again.
Today we know John Tyndall's breakthrough as the greenhouse effect. He proved that carbon dioxide wasn't as innocuous as once believed, and identified one mechanism by which climate could change. To him, it was a solution to the past problem of why the mountain glaciers had melted. Yet scientific speculation persisted. If the climate had changed once, could it change again? Was the climate now fixed, or was it still fluid? The question begged an answer, but hard facts were thin on the ground. The climate was one big unknown. Records were either patchy or non-existent. Into this scientific void stepped a group of intrepid Victorian meteorologists. Men like Clement Wragg. Wragg worked for a body called the Scottish Meteorological Society, whose lofty mission was to understand and predict the weather, including the extremes that could be found on top of Britain's highest mountain. Ben Nevis. But first they had to record the weather regularly.
Between June and October in 1881, Rag made this climb every day, sometimes in appalling weather conditions. His personal grooming took a bit of a hit. He became known as Inclement Rag.
With interesting results coming in, the Society decided to open a permanent weather station on the summit and started a fundraising campaign to which Queen Victoria herself contributed £50. Work started in the summer of 1883 with a bridle path 5 miles long snaking its way up the mountain. And a year later, the sturdy weather station was ready.
And here it is. This is it. This is the ruins of the observatory that they built in the summer of 1884. Around a timber frame, they constructed walls that were up to 12 feet thick. And on top of the walls, they built a wooden tower where they kept the instruments with a door on the outside so that even when the snow almost buried the thing, they could still take their measurements.
Rag and the other observers were led by one Alexander Buchan, who became known as the founding father of meteorology. He understood the importance of making measurements that might one day reveal patterns of greater significance.
Alexander Buchan was the chief scientist here. It was him who organised the programme of work, which mainly consisted of taking pretty standard readings that even a gadget like this can get. So for example, let's get this little fan here that whirls around telling me the wind speed. It's just under 1.5 miles an hour, which is pretty extraordinary because it can gust up to 100 miles an hour here. It also tells me that the temperature is just under 10 degrees Celsius and that the pressure is 862 millibars. I mean, it's odd that this little electronic device captures in an instant what those pioneers over 100 years ago struggled to measure.
Day after day they made their readings, undeterred by the severity of the conditions they encountered.
These stones bear witness to the days of manual measurement, to the days when you had to be there to actually write down the data, the hard slog of gathering facts which the Victorians excelled at, and through which the Victorians laid bare those hidden mechanisms in nature. There was nothing glamorous about what they did, but the scientific findings that emerged were glorious.
Perhaps none more so than the importance of record keeping itself. By establishing a tradition of basic data collection, the early meteorologists gifted future generations a way of discovering that the globe was warming, and by how much. And while Buchan and his colleagues were establishing the climate's baseline, other scientists were beginning to speculate about the impact of carbon dioxide on it. In 1896, a pair of Swedish scientists, Svante Arrhenius and Arvid Högbohm, built upon John Tyndall's findings by proposing that emissions of carbon dioxide from burning coal and oil might one day warm the planet too much, bringing about global warming. They began to do the sums. They figured it would take around 3,000 years for the CO2 to reach dangerously high levels, levels dangerous enough to warm the planet. But the Swedes were wrong. Edinburgh's Scott Monument was started in 1844 at the height of the Industrial Revolution. It commemorates the writer Walter Scott, but it's also an unintentional monument to the age of carbon.
It's hard to believe that this monument was built of a beautiful cream-coloured sandstone, Binney stone, which contains a residue of oil shale, and it's that residue that acts as a kind of glue, sticking the soot and smoke particles to the outside of the stone. That's why it's so black. The dirty appearance is the residue of fires and smoke from the 19th and 20th century.
The fires may have gone out, but some of the CO2 they released over 100 years ago is still with us.
So is this a good place to measure? We're high enough up?
It's a perfect place to measure if you want to measure how much carbon dioxide is in the air above Edinburgh, but particularly above Princes Street.
So what value is it giving us then?
At the moment, we're at about kind of 380, 390 parts per million of carbon dioxide. And that's about right for the globe at the moment. That's the atmospheric concentration pretty much around the planet, which is a huge increase on what the concentration of carbon dioxide was when this monument was built.
Yeah, so what was it back in the Industrial Revolution then?
It was about 290.
Right.
So we've had an increase of about 100 parts per million in, what, about 150 years or so.
That additional 100 parts per million of carbon dioxide, most scientists now believe, is helping to warm the planet. In Scotland, the average temperature has increased by almost 1 degree since records began.
So how confident is the climate science community that this is a real trend?
Very confident. The level of consensus is greater than any other area of science. By looking at the geological record, we know that the sun's really important. It's an important natural driver of climate change. We know that volcanic activity, also very important. But when we look at contemporary climate change, the rapid warming we've seen in the last 50 years or so, those natural drivers can't explain it. What does explain it is the rapid increase in greenhouse gas, carbon dioxide concentration.
Natural climate change made its impact felt on Skara Brae and Culbin Sands. But today it's the carbon dioxide of our industrial era that's stoking the Earth's temperature. Coal is no longer king in Scotland. The era of steam and shale oil has long since passed, and Tennant's stock was dismantled years ago. They might represent Scotland's past, but the greenhouse gases they began to release will help shape our future.
Pretty easy to get rid of the smoke, grime and filth of the Industrial Revolution. You just scrub it out. But scrubbing carbon dioxide out of the atmosphere, well, that's something completely different. For me, it's beyond reasonable doubt that our greenhouse gases are stoking the warming of the planet, and that the impact of that can be seen in various corners of the world.
What's much less clear is what that impact will be in the future. Much depends on the extent to which we can reduce carbon emissions. The most recent report from the Scottish Environmental Protection Agency projects that by 2080, annual summer temperatures in Scotland could be anything between an optimistic 1.2 to a catastrophic 6.8 degrees centigrade. Their middle of the range forecast points to a 3-degree rise. In this new, warmer Scotland, the growing season may extend by around 33 days. As temperatures rise, new crops that were once unthinkable become viable. Crops like grapes. On the banks of Loch Tay can already be found Britain's most northerly vineyard. It's hoped that in a couple of years' time the yield here will be good enough to produce wine. But global warming won't mean warm, dry weather all year round. We're already seeing significant change. This is a rain gauge which collects daily rainfall. And it's thanks to instruments like this scattered across the country that we know Scotland is getting much wetter. In the last 50 years, total rainfall's up by 20%. And in winter rainfall is up by nearly 60%. So this is now the average amount of rainfall that we get in the west of Scotland. And the bad news is there's more rain in store. Projections are that by 2080, there'll be an additional 20% of rainfall in winter. Brilliant.
Now, apparently the Inuits have about 50 words for snow, but I think the Scottish have about 100 words for rain. And this is Stoughton.
Even if we currently do have 100 words to describe rain, we might still need to invent some more. Because the kind of rainfall Scotland can expect will be very dramatic and rather unfamiliar. Sudden torrential downpours. Deluges that will cause existing city drains to overflow. And rivers to burst their banks. The Scottish Environmental Protection Agency estimates that the flow rates in some of Scotland's rivers has already increased by 40% in the last 25 years, and is projected to increase again. Unchecked, climate change could be catastrophic. But unlike the people of Skara Brae or Culloden Sands, we now have the knowledge and technology to do something about it, should we choose to. Scotland can lead the way in reducing its carbon dioxide emissions. The target is to cut them by 80% by 2050. And just as Scotland's natural resources, its oil and its coal, helped us kickstart climate change, others might now be used to combat it. Nature has already provided one potential weapon. One that forestry scientists are busy testing.
Forestry is a very simple way to take carbon dioxide out of the atmosphere. Nature has produced a fantastic tool to do that. It's a tree. As the tree is growing and actively photosynthesizing, that process takes in carbon dioxide, which a tree then quite nicely for us converts into wood, into a solid form of carbon.
It seems such a simple system that we've kind of taken for granted.
We couldn't have designed it better if we'd asked a million boffins. As all the scientists in the world will tell you, we haven't got a lot of time to get our house in order. So forests that establish quickly and grow quickly are going to give us that quick fix of carbon.
So presumably some trees are better than others.
There's one that's native, that's Scots pine, but then there's several others that are non-native, but they're phenomenally productive.
Like Sitka spruce?
Sitka spruce is the key of those species. We understand it very well. We've done forestry for decades using this species, and it produces a forest quickly, and it stores a lot of carbon. But we're also looking into other new exotic species, including eucalyptus.
Eucalyptus comes from Australia and loves warm, wet weather. It also grows faster than almost any other species that the Forestry Commission has ever tested.
You know, if you're looking for a sign that our future forests are being designed with a warmer climate in mind, then you just don't need to look beyond these eucalyptus saplings. The fact that this tree grows like the clappers to, within a few years, lock in tons of carbon dioxide just underpins the urgency, the impetus that climate change has in forestry circles. Plus it smells nice too.
Eucalyptus plantations would transform Scotland's landscape. And they would do it quickly, taking perhaps as little as 25 years to grow into mature forests. But even fast-growing trees will capture only a fraction of the carbon dioxide we continue to emit. They might eventually help to check climate change, but they won't stop it in its tracks. A more immediate way to tackle the problem is to find sources of energy that are not carbon-based. It's a challenge that Scotland is particularly well placed to meet. Because just as Scotland once had carbon-based energy in abundance, today it has new sources of natural energy in abundance.
120 years ago, when James Watt's invention reigned supreme, and when carbon was fueling the global economy, a Scottish scientist was busy inventing the world's very first wind turbine.
James Blythe was Professor of Natural Philosophy at Anderson's College, Glasgow. His interest was producing electricity from the wind, and he set up a laboratory at his holiday home in Marykirk in Aberdeenshire.
Hello. I know this is going to sound mad. Can I see your back garden?
Yeah, just go straight now.
All right, thanks then. I've got the photograph, and this is Blythe House, so this should be it. It's taken from over here, I think. So that's the two windows up there, 3 along here. So this is the big extension. This shed was there, I guess. So somewhere around the site of this apple tree was the world's first electricity generating wind turbine.
Blythe stored his wind power in batteries in his shed and used it to light his holiday home.
He might have built a wind turbine at the bottom of his back garden, but Blythe was no mad professor. He got a patent for the system, and in fact it worked so well that it generated lots of surplus power. He offered that surplus power to the people of Marykirk to light the main street, but they refused on the grounds that electricity was the work of the devil. So Blythe did the devil's work for the insane instead. He built another wind turbine for the Montrose Lunatic Asylum. It ran for nearly 30 years.
Blythe believed that wind generation was a much better bet than fossil fuels. But Blythe was a lone voice. Born in the age of carbon, wind power never really had a chance. Another century was to lapse before Britain took the simple step of scaling Blythe's invention into a fully functioning wind farm. Now they're rising all over the country.
Blythe was a prophet before his time, and now, just over 100 years after his death, I wonder what he would have felt about this site. He'd probably have felt vindicated, proud even, and probably astonished that his primitive designs have evolved into these powerful, sleek machines, each turbine producing 750 times the power of the one that lit his holiday home in Marykirk.
Once we were at the mercy of wild weather, like the wind. It shaped our way of life, even whether we lived or died. But today, we can harness even the worst extremes of the world's weather. This is the Grind of Navier on the northwest coast of Shetland. Fantastic name. Fantastic site, and up till recently, a field of boulders that presented a geological mystery.
It's surreal. Looks like some giant's been chucking stones or something. I mean, look at this one. This is colossal. So how did they get here? It sounds incredible. I mean, they're so huge, but they've been moved here by the sea. I mean, some of them have been picked up from beneath the waves in huge storms and just dumped on shore, but most of them, it's the power of the waves barreling through that gap in the cliff face there. It's been carved out by erosion and forcing its way down onto these rocks, almost like a jackhammer prizing blocks apart. You can see some fresh surfaces here where blocks have been removed, maybe in the last few winter storms. And then what happens, these blocks then get just taken out of here and dumped inland, sometimes 80 metres or so inland. I mean, the power of the waves and the wind to transform this landscape is utterly awesome. Imagine that we could capture the power of a wave that can move a mountain. Think of the energy that could be produced, the carbon that could be saved. The seas around the north coast of Scotland are some of the strongest waves and tides in the world. That's an enormous source of untapped and renewable energy.
But transporting electricity from remote sites like Shetland, whether generated by wind or wave, comes at a price. Pylons, 65 metres high, are planned to carry power cables from Scotland's northeast to the central belt, across 137 miles of some of the finest Highland scenery. This is a simulation. The reality will follow soon. Carbon withdrawal isn't going to be pain-free. We've come a long way in the last 10,000 years. Superstition has given way to science. We might not have mastered the weather, but we've come to understand it. The genius and geology of Scotland gave us the Industrial Revolution, carbon and climate change. Now, I like to believe that Scotland can help propel the world into a new and cleaner age.
One son of Scotland, James Watt, kick-started the Industrial Revolution. And perhaps another great Scot, James Blythe, will be the forerunner of the next one. The transformation of our carbon economy into a green one. And what a revolution that'll be.
Two short trips to the coast coming up next here on BBC HD. Then at 7:25, Jim Carrey stars as Bruce Almighty.